So we are starting into carbohydrate metabolism. It also is known in the other chapter book as biochemical energy production, chapter 12. We're going to be starting to shift back to the other book. So those of you that are in this class, remember that the other book is underneath the microwave on the west side of the classroom. It is the blue book, the Seeger-Slaybaugh book. We're going to use that for the end of the year, but you might want to still keep your other book as reference because it has a lot of things more concise. So, carbohydrate metabolism or biochemical energy production. Please go grab one of those books. Pause the video if you need to, quickly, because we're going to do a case study real quick at the very first of this chapter. The case study that we're going to look at is on page 746 and 767. So this is the very beginning of the chapter and at the very end of the chapter. So this is something near and dear to my heart. What are the symptoms of diabetes and what are some of the complications of diabetes? So pause the video, take a second, and answer those questions real quick by reading that study. Okay, as we're coming back together, I'm not here with you, so I want you to take a few minutes and pair share with somebody next to you about what did you find out? What things did you learn when you were reading this section? Go ahead and do that now. All right, did you get the same stuff out of the study that the person next to you did? Did you figure out some things that, the complications of diabetes, some things that could happen? Before I got diagnosed with diabetes, I didn't know any of that. And it was an eye-opener to be diagnosed with that. So, some classic diabetic signs that you must not miss: frequent urination, unexplained weight loss, increased thirst, excessive fatigue, weight gain, slow healing, excessive sleep, blurred vision. I can tell you, yes, those all happen. Diabetic ketoacidosis. Signs of diabetic ketoacidosis, early signs are you feel thirsty all the time, you urinate often, you have high glucose levels and high ketone levels in the urine. If it's not taken care of, if you don't control your diabetes like Larry Miller didn't, you start feeling weak or constantly sleepy. You get dry, flushed skin. You get nausea, vomiting, pain in the abdomen, difficulty breathing, and sort of like a fruity smelling breath. So there's a lot of things that can go on. Some of the complications of diabetes, dental disease is one that is often. Complications of pregnancy, hypertension, which is high blood pressure. Eye problems leading to blindness, amputations, nervous system diseases, heart disease, and stroke are all things that are complications of diabetes. Other things, skin infections now become a big deal. And I lost 2 friends to skin infections that are diabetic. They had skin infections on their feet. Diabetic retinopathy, start losing your sight. Arteriosclerosis, where they start having problems with the arteries heading into your heart damage. Permanent kidney damage, problems with your bones, fatty liver. I could almost say yep on each of those. And it came about without me knowing it was happening until it was too late. So what can happen because of that? Blindness, heart attack, kidney failure, and even amputation. Often of the limbs, the fingers, the toes, the feet. So let's talk about this digestion of carbohydrates. As we go through polysaccharides, we have starch, it becomes maltose and then glucose. Sucrose becomes glucose and fructose, and then lactose becomes glucose and galactose. Over here, notice that we are using enzymes. The enzymes have the ACE ending. We've got amylase, maltase, sucrase, and lactase. And we need to know that what breaks down what. Amylase is usually found in the mouth, and that's our saliva. And if we try to eat starch without chewing it very much, then it has a hard time digesting and going through things. So chew your food is an important thing. So blood glucose, when we talk about blood glucose levels, I'm trying to get things so you can see it. That's the amount of glucose present in your blood, and it's usually expressed in milligrams per 100 milliliters of blood. When we're said to be hypo, remember hypo means less than, so when we had hypochloric acid, it was less oxygen. Hypoglycemic is lower than normal blood sugar. Hyper is higher than normal blood sugar. So a lot of times as a diabetic, you're trying to keep from going either hyper or hypo. Because if they give you medicine, it lowers your blood sugar. If it lowers it too much, you're hypo. If it doesn't lower it enough, then you're still hyper. And being a diabetic anyway, your body wants to be hyperglycemic. Renal threshold. Renal has to do with the kidneys. So this is the blood glucose level at which glucose begins to be excreted in the urine, meaning I can't handle any more glucose in my system and it's coming all out. Glycolysis is a series of reactions in which glucose is oxidized to glycogen. Okay, going forward. These charts right here sort of tell you what a good normal blood glucose is and what an A1C is. An A1C is a measure of how well your blood glucose is over a 3-month period. So they're able to look back over a 3-month period and see what's good and what's bad. This one right here says it's 8 and 7 are good. If you talk to my doctor, he's more, that's the one on the upper left hand, he's more on the one on the right where it's green, where it says 6 and 4. That's where he wants you to be. 7 is borderline, often called pre-diabetic, and they actually put you in stuff as you get closer to 8, he says it's diabetic. So as far as normal glucose fasting, 80 to 100. For a diabetic, we're lucky if we get it between 90 and 110. So that's fasting. So you sort of see what's going on here. The problem becomes when you get high or dangerously high blood glucose, you start losing the ability to do things, or dangerously low. You become confused and it's really hard to do just normal stuff. So glycolysis, let's look at what's going on here. You will need to know this pathway and need to know what's going on. I like this one because it sort of showed all the way. It looks like I enlarged it just a little bit too big, so it's going off the chart. But it does also in your book. So it starts the same for each of them. You start with glucose through ADP becoming ADP, ATP becoming ADP. You get glucose 6-phosphate. And then you move to fructose 6-phosphate. And another ATP comes in to becoming ADP, and you get fructose 1,6-biphosphate. At this point, it splits. And you get 2 pathways that go down there. And you start using your NAD plus and NADH, and you're still using ATP. And you can see that through glycolysis, we end up with a final product. I'm going to pause this for a minute and go in and shrink these up a little bit so you can see the things. Okay, so I shrunk it up a little bit so you can see the bottom of this one. You get pyruvate, and pyruvate is important for our next step. We call it the fates of pyruvate, so let's go ahead and go on to the next page. When we have glycolysis, we end up with pyruvate. We get a net of 4 ATP formed, 2 ATP used, so we get an overall positive with glycolysis of 2 ATP. We also get from glucose to 2 pyruvates. So we end up getting 2 pyruvates through this process. And we end up with a positive 2 NADH and 2 hydrogens that are 2 protons available. And I've put up I hope you were noticing at the top here, I put what page that's on in the Seeger-Schleybaugh book. It's on page 749. All right, so then we get this cycle going through where we sort of get these loops, or the fates of pyruvate. And you can sort of look at that. I'm going to be showing you a couple videos coming up through the next couple days that will hopefully explain this a little better. But you do need to know these cycles, and you need to know what's going on in each of the cycles to do well in this test. So let's look at our books again. We're going to go to Ask an Expert in 23.1, and how can we avoid energy crashes? I know a lot of kids say, well, I'll just drink this energy drink and I'll be fine for the rest of the day. And then they start drinking 4 or 5 Red Bulls a day, and then they get more and more and more and more. And they have these crashes, and all of a sudden, boom, they're out. Doesn't matter what's going on. So let's go ahead and go to this YouTube site and watch that. Okay, we're not going to go to that site. Sorry, I put the wrong site up there, so I just took it off. So just go ahead and read from your book. It's called Ask an Expert 23.1, and I want you to pair share or discuss with a neighbor what you found out. Go ahead and pause the video, give yourself 5 minutes to do that, and come back. Okay, I am back. So hopefully you had that 5 minutes and you had a chance to talk about how to avoid mid-afternoon energy crashes. So when we look at the fates of pyruvate, okay, so I would like you to stop here and bring in the fates of pyruvate video. So stop this video and start the fates of pyruvate and then come back. Okay, so now that you've seen the fates of pyruvate, you can see that there's 4 directions that pyruvate can go, 4 different things that pyruvate can do. And one is aerobic, one is anaerobic, one takes place only in yeast, and one is the oxalo acetate. So let's go forward. There's 3 fates produced by glycolysis. The anaerobic, we talked about that, lactate, and that's where your muscles get sore. The aerobic, where we get the citric acid cycle going and we get acetyl-CoA, and the anaerobic, where we have alcohol fermentation, where we get ethanol. So the next thing that we hit is the citric acid cycle. This is a series of reactions in which the acetyl-CoA is oxidized to carbon dioxide and reduced forms of coenzymes FAD and NAD, and you're going to get to know these really well. Stage 3 in the oxidation of the fuel molecules. It's the summary of the citric acid cycle is listed right here. It's also in your book, and you probably will want to look at the book and look and see how that citric acid cycle goes together, and where does NADA or NAD and NADH and FAD and FADH, and where everything is in there and how it works. Each cycle for oxidation reduction reactions produce NADH, and 3 of them, and 1 FADH2. So sort of important there. So take a second, look in your book, 23.5, look at the citric acid cycle, and just sort of get familiar with it. You're going to need to know it. This is what it looks like. And so you can sort of see what's going on. I like this one because it shows you the actual structures as you're going around, what is happening to each of them. You're going from a C2 to a C6, C6, C5, C4, 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 and back, where these 2 combine and make a C6 again. So you can sort of see what's going on as you come around. I like it because the NADH is in blue, so it's really easy to see that coming on. GTP and GDP are in red, so they're easy to see where they're happening. Just sort of really become familiar with this cycle. So the net ionic equation for the citric acid cycle is this. Oh my goodness, really big. But basically, what are we getting? We're going from 2 phosphates to 3 phosphates. Okay, 2 carbon atoms are completely oxidized to get 2 CO2s. So we're getting them out right here. This is becoming down here. And you can just sort of see your H is getting added here and here. And you got 3 hydrogens that are liberated. Okay. Then we're going to go on to the Krebs cycle. I believe this was where, let's see, let me really quick. Yes, we got just a little bit more to go, sorry. The first steps of the citric cycle help us to regulate production. The ATP and NADH inhibit the citric synthesis, so if I've got too many of them, it slows that down. ADP stimulates it, so it wants more. The third step, we've also got, there are 3 regulation sites. These are the ones that I like to turn on and turn off switch. The third step, and you do need to know these. So the first step, the third step, and the fourth step. And they're either inhibited or stimulated by, most of them are stimulated, in fact all of them are stimulated by ADP. They're inhibited by NADH on all of them, ATP on 2 of them, the first and the third, and succinyl-CoA on the fourth. So you've got some common things that are inhibiting, so if you can get them in your head, the common things that are inhibiting, and the stimulant is the same. If I have too much ADP, I'm trying to stimulate the citric acid cycle to make ATP. So at this point, I would like you to watch the electron transport chain. So go ahead and pause this video and get the electron transport chain up. Okay, I know it's a little bit annoying of music, but it will help you, I think, remember what's going on. So as we're looking at the electron transport chain, we need to be looking at what's actually happening here. We've got glycolysis happening that goes into the Krebs cycle, which goes into the electron transport chain. Each of these producing an ATP. ATP is sort of our energy. Electron transport chain, you can sort of see what's going on here. We also have gone over that. So hopefully in the videos that you've seen, hopefully that will help you to understand what is going on. Remember, ATP is what we're trying to get to here, the energy that we need. Okay, so now we're going into oxidative phosphorylation. Turn to your books on page 758. We're going to be going over that while you watch the video. The synthesis of ATP is a phosphorylation, basically putting phosphate on, and is linked to the oxidation of NADH and FADH2. So go ahead and let's watch this chemostatic hypothesis, and is the LEAF video. Okay, hopefully you've had time to watch that and come back, and we're going to start going forward. And that's the end for today. We'll start this video next time. So if you would work on your assignments, please, and we'll get going with what you need to know. Thanks.